NASA's plan to save the Earth. The Earth is surrounded. Asteroid collisions, hurricanes, and volcanic eruptions serve as everyday reminders that life on Earth could cease at any time. Although we all hope for the best, preparing for the worst-case situation is important. NASA's Double Asteroid Redirection Test, DART, will launch a spacecraft or missile at an asteroid to see if the impact power might save the Earth in the worst-case scenario. Are you curious how NASA intended to preserve the planet? Finish watching this entire video. In November 2022, NASA will conduct the Double Asteroid Redirection Test, DART, illustrating how to divert asteroids that threaten Earth. Natural disasters, climate change, and the potential threat of asteroids are constantly present on the globe. However, NASA has a strategy to safeguard humanity. The Double Asteroid Redirection Test, DART, will launch a spacecraft or missile toward an asteroid to see if, in the worst-case situation, the impact power can save Earth. But what specifically does NASA want DART to accomplish? In this video, we cover everything from the goal of DART's mission to the technical specifications needed to make it work scientifically. Watch the entire video to learn how NASA helped save the planet. Please give this video a thumbs up and subscribe to this channel for more, just like before we continue. Click the bell icon to receive notifications of new videos. Did you do that already? Let's get going. Mission background. The DART mission is sponsored by NASA's Planetary Defense Coordination Office, which controls planetary defense operations. We must all take action to safeguard our world. Bill Nelson, the administrator of NASA, observed, after all, it's the only one we have. This mission demonstrates NASA's ongoing efforts to be prepared for whatever the universe may bring. NASA has shown that we are committed to protecting the environment. This is a turning point for planetary security and humanity, showing the dedication of NASA's world-class team and partners. The international collaboration between Hera and Ada. The Hera mission, a part of the European Space Agency's ESA Space Safety and Security Initiatives, is scheduled to launch in 2024 and arrive in the Didymos system in late 2026, or around 4 years after DART's impact. Hera's primary spacecraft and its two auxiliary CubeSats will undertake thorough surveys of both asteroids during its mission, focusing on the crater or other surface disturbances caused by DART's crash and an accurate estimation of Dimorphos' mass. Hera's thorough post-impact investigations will greatly improve the knowledge gathered from DART's asteroid deflection test. ADA, Asteroid Impact and Deflection Assessment, is a big worldwide collaboration that includes members of the DART and Hera teams. ADA aims to produce the most accurate knowledge from the first demonstration of an asteroid deflection technology by combining data from NASA's DART mission, which include ASI's Lichia Cube and ESA's Hera mission. ADA is an international collaboration between planetary defense and asteroid science researchers. The ADA collaboration serves as an example of underestimating that planetary defense is an international endeavor and that scientists and engineers worldwide work together to find solutions to planetary defense-related problems. Description of the spacecraft. The DART spacecraft, an impactor with a mass of 610 kilograms, 1,340 pounds, was equipped with only sensors for navigation and no research payload. Camera. Draco supported autonomous navigation to impact the asteroid's moon near its center and was based on the Long-Range Reconnaissance Imager, LORI, on board the New Horizons. Draco's optical system consisted of a Ritchie-Chrétien telescope with a telephoto lens having a 0.29 degrees field of vision and a 2.6208 meters focal length. Images captured right before the impact are anticipated to have a spatial resolution of about 20 centimeters per pixel. The instrument weighed 8.66 kilograms, 19.1 pounds. The camera's detector was a CMOS image sensor with a resolution of 2560 by 2160 pixels. The detector captures wavelengths between 0.4 and 1 micron, visible and near infrared. The exceptional low-light performance expected of LORRI during its Pluto flyby was not necessary for Draco. Thus, a commercial off-the-shelf CMOS detector was utilized in its place. Due to advancements in sensor technology during the 10 years between the designs of LORRI and Draco, Draco's detector performance matched or exceeded that of LORRI. The Draco photos were fed into an onboard computer with anti-missile technology-derived software, which enabled DART to independently steer itself to its crash. Solar panels. The solar panels aboard the spacecraft were built using a rollout solar array, ROSA, design tested on the International Space Station ISS during Expedition 52 in June 2017. A small portion of the DART solar array was set up to demonstrate transformational solar array technology using the ROSA structure. This technology uses highly efficient Sol Arrow inverted metamorphic IMM solar cells and reflective concentrators to produce 3 times as much power as other current solar array technologies. Antenna. Spiral radio line slot arrays, a novel high-gain communication antenna, were initially used by the DART mission, RLSA. The circularly polarized antenna has a gain of 29.8 dBi on the downlink and 23.6 dBi on the uplink, and operates in the X-band NASA Deep Space Network, NASA DSN, frequencies of 7.2 and 8.4 GHz. The constructed antenna, which has a flat and compact shape and has been tested in various situations, exceeds the specifications and has a TRL-6 design. The ion thruster. The DART mission employed the next gridded ion thruster, a type of solar electric propulsion. It generated the 3.5 kilowatts required to power the NASA Evolutionary Xenon thruster commercial. Next C engine using solar arrays of 22 meters squared, 240 square feet. Early ion thruster tests discovered a reset mode that caused more current, 100 amps, than anticipated to be induced into the spacecraft's construction, 25 amps. The mission could be completed without the ion thruster by utilizing conventional thrusters. Hence, it was decided not to use it any further. To handle emergencies, the ion thrusters were still available, and had DART missed its destination, the ion system could have brought it back to Dimorphos 2 years later. Additional spacecraft. The Lycia Cube, light Italian CubeSat for imaging asteroids. A small CubeSat tagged along with DART and split on September 11, 2022, or 15 days before impact, was a backup spacecraft donated by the Italian Space Agency, ASI. As it passed by the asteroid, it took pictures of the impact and ejecta. Lycia Cube interacted with Earth immediately and transmitted pictures of the ejecta following the Dimorphos flyby. Lycia Cube has 2 optical cameras that go by Luke and Laia. The perfect target for DART's mission is Didymos. The Greek term Didymos, which translates to twin and explains why the mission's name contains the word double, refers to the binary asteroid system Didymos. Didymos is the best candidate for humanity's first planetary defense experiment, even if the planet is not in danger of being struck by it, and is therefore not in danger from it. 2 asteroids make up the system: Didymos, a bigger asteroid with a diameter of 780 meters, 0.48 miles, and Dimorphos, a moon-like asteroid with a diameter of 160 meters, 525 feet, which orbits Didymos. Dimorphos will orbit Didymos for 11 hours and 55 minutes before DART's kinetic collision, and there will be a 1.18 kilometers between the cores of the 2 asteroids, 0.73 miles. Dimorphos's period in orbit around Didymos was shortened after the DART probe nearly collided with it. While seen from Earth, the Didymos system is an eclipsing binary, which means that as Dimorphos orbits the bigger asteroid, Didymos passes in front of and behind it. To establish Dimorphos's orbit, telescopes on Earth can monitor the regular fluctuation in the brightness of the combined Didymos system. To allow for the best possible telescopic observations, the DART collision was timed for September 2022 when the distance between Earth and Didymos is at its shortest. When the DART hit, Didymos was still around 11 million kilometers, 7 million miles from Earth. Still, telescopes worldwide have contributed to the Global International Observing Mission to ascertain the impact's effects. The DART demonstration is a carefully thought-out design. According to current projections, Didymos' orbit does not cross that of Earth at any point. Since DART's energy delivery to Dimorphos is rather small, the asteroid cannot be disrupted. At the time of its kinetic collision with Dimorphos, the DART spacecraft weighed around 570 kilos, 1,260 pounds. Dimorphos' mass has yet to be precisely measured. However, it's predicted to be about 5 billion kilograms using assumptions about the asteroid's density and size. This release contains additional specific information regarding the Didymos binary asteroid system and the proposed kinetic impact geometry for DART. Additionally, the kinetic impact of DART is intended to shift Dimorphos' orbit so that it is a little bit closer to Didymos. Should an asteroid ever be detected, the DART mission demonstrates the ability to respond to a potential threat from an asteroid strike. DART is a spaceship created to crash into an asteroid as a technological experiment. The asteroid DART's target does not pose a risk to Earth. Should an Earth-threatening asteroid be found in the future, this system is the ideal testing ground to see whether purposefully crashing a spacecraft into an asteroid may successfully convince it to reverse its course. Only around 40% of such asteroids have been discovered as of September 2022. Even though no known asteroid greater than 140 meters in size has a serious risk of hitting Earth for the next 100 years. The Double Asteroid Redirection Test, DART, NASA's first planetary defense test mission, aims to test and evaluate a strategy for defending Earth during an asteroid impact threat. The DART mission successfully crashed a spacecraft into Didymos, the smaller asteroid in the binary asteroid system, changing the asteroid's orbit through kinetic impact. DART was the first mission to study and demonstrate one technique for deflecting asteroids by altering the trajectory of the asteroids by kinetic collision. A fantastic way to demonstrate whether we could protect Earth from an asteroid strike in the future is to use NASA's DART test. It is slated to launch in November 2022 and will offer useful information that could aid planetary protection. Thank you for watching, and pay attention to this test. The video has come to an end. Don't forget to subscribe to the channel and give this video a thumbs up if you enjoyed it. Remember to click the bell icon to get alerts when new videos are posted. For the time being, bye until the next video.